So let's work for another example here. I want to find the first derivative, f prime of x, for f of x equals 1 over x. Then find the equation of the tangent line once again. And let's go ahead and graph both functions. Specifically, I'm looking at the tangent line at the point 2 and 1/2. So I need the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Now I'm kind of partial to this particular form, but you don't have to do this form. You could use the a plus h, as long as you know what a and h are and so forth, and you'd be just fine. So in this case, this is going to be the limit as delta x goes to 0 of 1 over, this is x plus delta x, so that's 1 over x plus delta x, minus 1 over x all over delta x. So I need to do just a little bit of algebra. So I'm just going to do this operation, this subtraction, and that would give me x minus the quantity x plus delta x over x times x plus delta x. And this is all over this delta x, which is the same as just bringing it up. So I'm just going to bring it up right here. Now, when I drop these parentheses, I'll get x minus delta x over x. Whoops, that wasn't an x. I was thinking a step ahead there. X delta x. I'm just moved that over there is all I did. Times x plus delta x. Well, these x's are going to cancel. This delta x is going to cancel. So I'm going to end up with, I'm going to go back to the limit now, as delta x goes to 0. What I'm left with, because this delta x canceled out, is a negative 1 in the numerator, so negative 1 over, let's distribute this x, and I will get x squared plus x times delta x. Now I can take the limit. As delta x goes to 0, this delta x goes to 0, so this component goes to 0, and I end up with negative 1 over x squared. Now that is the derivative function. So what is the value of the slope for the tangent line at the point 2, 1? Well, I need to evaluate this at x equals 2. And when I do, I'll get a negative 1/4. So now to find my tangent line, again, I go with y minus y1 equals the slope times x minus x1. And then I'll have y minus a half equals a negative 1/4 times x minus 2. So that would then imply that y is equal to negative x over 4 plus 2 over 4, which is plus a half, plus a half. So my equation of the line tangent is going to be y equals negative x over 4 plus 1. So let's go ahead and take a look at Maple, a graph of that and a graph of the original function. So in Maple, I'm going to type plot and then put the curly cues because I'm going to do more than one function. And let's do f of x first, which is just simply 1 over x. And then the line tangent is negative x over 4 plus 1. Let's close that up. And then let's let x go from, let's say 0 to 5 should be plenty. And I let y go from, let's go below the x-axis just a little bit. Negative 1 to, 2 should be enough. And again, I'm going to increase the thickness just a little bit to make it easier to see on the screen. And there's our function. So here's my original function, and here's my line tangent. And at the point 2, 1, the slope is, as we said, a negative 1/4. And you can tell it's negative 1/4 just by looking at it, because I'm at x equals 1. So I'm going down 1 and over 4. I mean, from basic algebra, you remember that is how you determine graphically the slope of a line. So this slope really is negative 1/4.